All right. Number 19 in work and energy multiple choice set 2 says a ball is dropped, comes down, bounces off the floor. Its speed is the same immediately before and immediately after the collision. So whatever the speed is here, notice speed does not include direction. So if it, just before it hit the floor, if it was going 5 meters per second, right after it bounces off the floor, it would also be going 5 meters per second. If we were looking at it from velocity, one would be negative, the other would be positive. But they just say speed, so we'll just worry about magnitude. Well, all right, so just before it hits, where did it get its kinetic energy that it had here? Well, it got it from its height, right? It was dropped from rest, correct? Dropped, yeah, we're assuming it wasn't thrown down. So whatever its potential energy up here was, gravitational, is all turned into kinetic. Well, in this case, and this must be some theoretical, magical thing because this never happens in the real world, it bounces off with the same speed, so it has to have the same kinetic energy. Well, if it has the same kinetic energy after bouncing, it's got to lose all that back into potential here, so it's going to have the same potential energy at the back. And the same potential energy at the end means same height, because the mass doesn't change. So, yeah, the fact that it has the same kinetic energy going in and leaving means it has to have the same height. Now, in the real world, what happens is the ball never bounces off just as fast as it came in. It might come in at 5 meters per second and leave at 4. Because in the process of bouncing, some of that kinetic energy is transferred into heat. There's friction within the ball as it deforms. So the ball comes in and it bends and deforms and then bends back again. There's friction in there. So it would lose some of that kinetic energy, have less kinetic energy coming off the floor, and wouldn't bounce to as high, which we know. If you drop a ball and it bounces, it never comes back right to where your hand is. The only time it does, you might think that it does that is like when someone's dribbling a basketball. But keep in mind, do people drop the ball when they're dribbling it? They give it a push downward, right? And a talented basketball player knows just how hard to push, just how much extra kinetic energy to give it when he lets go, right? Because he's giving it just a little push to give it some kinetic energy. So in the case of dribbling a basketball, it's not dropped. The beginning energy is both gravitational and there's some kinetic. And a good basketball player knows just how hard to push it to give it enough velocity so that when it comes back up, it's pretty much just, stopped or close to it at their hand. Or if they need it to come up quicker, then they drop it and they push it even harder. So there's careful, all right? We're talking about dropping the object, not throwing it downward. If you drop a ball, it never comes back up to the same height. But in a theoretical sense, I guess in this case, we'll let it happen. Let's look at the answers and see. So the height, it should be the same. Yeah, should be the same. Okay.